In this lecture, we're going to start discussing transport aircraft flight controls. And the flight controls are contained in ATA Chapter 27 for the aircraft documentation, maintenance manuals, and that kind of thing. So some of the flight controls should look familiar from small aircraft systems. So primary flight controls, including things like the ailerons to control roll, elevators to control pitch, and rudder to control yaw, are the same basic concept, just scaled up for transport aircraft. And there may be, in the case of things like most of these flight control, there may be multiple. So there may actually be like things like inboard and outboard ailerons. The elevator may be split, or the rudder may be split into an upper and lower rudder that allows for redundancy. But the positions and the general operation, how they move the aircraft, is unchanged. Many small aircraft also have flaps as a secondary flight control, and that's no different here. Large aircraft, transport aircraft, all use flaps to increase lift at slow speeds. But sometimes the flaps aren't enough, and so most transport aircraft also have slats on the leading edge, which are panels that are able to droop down, and where flaps extend the trailing edge of the airfoil of the wing and increase its camber. Slats drop down forward in order to increase the area of the wing, increase its camber, and thus increase lift at a given airspeed, but at the expense of, for both slats and flaps, when they're down, they do cause more drag. There's going to be trim systems, the ability to trim things like pitch and roll and yaw. However, different from small aircraft, as most transport aircraft don't use trim tabs, but rather they have trimmable flight controls where we can adjust the neutral position. Or in the case of pitch trim, the entire horizontal stabilizer the angle of incidence of the horizontal stabilizer is able to be changed in order to adjust the pitch trim of the aircraft. And then finally, things you can see on the tops of the wings here are known as spoilers or speed brakes. And those can be used in a few different ways. So speed brakes, they can extend in order to create drag to slow the aircraft's forward motion in flight. And speed brakes are going to deploy evenly side to side, so the same number and deflection on the left and the right wing simultaneously. The other type of that are spoilers, and this aircraft shows roll control spoilers or roll spoilers as well as ground spoilers, and some of them are doing both jobs. Ground spoilers are tied into the weight on wheels switch and deploy across the entire width of the wing, typically on both sides, deploy when the weight on wheels sensor is triggered, when the aircraft gear is compressed by the fact that the aircraft touches down, and they get their name from spoiling lift, and they pop up in order to disrupt the airflow over the top of the wing in order to spoil lift, decrease lift on landing. There also are spoilers used in flight known as roll control or roll spoilers. And in that case, it can be as simple as one or two spoilers or several spoilers on one wing or the other that deploy, and they typically don't deploy fully, but partially deploy on the same side as the upward moving aileron or the downward moving wing. So in order to assist the ailerons, say we want to roll the airplane to the right, in that case, the left aileron is going to deflect downwards. The right-hand aileron is going to deflect trailing edge upwards, and the roll spoilers on that right-hand wing would partially deploy as well to increase the amount of downforce or spoil some of the lift on the right wing, in that case, to roll to the right. And the opposite could happen, to roll to the left. So in the case of rolling to the left aileron is going to go up. So some or all of the spoilers on the left wing are going to go up. And then the ones on the right wing aren't going to do anything. When we look at flight controls, we have to kind of break it down and look at flight control, actuation, and control. So control is how we send a signal to the flight control. And then that also includes a feedback or follow-up. How do we know that the flight control actually moved? And then the other part is the actuation method. And there's multiple different ways we can actuate a flight control. So at this point, you can see on the slides here, I have a video link. Normally I would show the video, but this video is linked separately on e-learning. So if you want to, you can either kind of watch this as we go, or once you're done watching this lecture section, then you can go watch the flight control video that goes along with this section. But here we have our loop of control. So the input is kind of everything that's the pilot or mechanic or whoever wants to operate the flight controls. We're going to move a yoke or a stick, and then that's going to be transmitted. And there's a couple different ways it can be transmitted. It can be transmitted mechanically, it can be transmitted electronically, depending on the type of flight control system, to something that is going to control the actual position of our flight control. So this is usually, it's some type of an actuator and valve, and for flight controls that are proportional or can be partially moved, such as an aileron or an elevator or rudder or other things like that, it's going to be some type of a servo valve. And we looked at the servo valve in hydraulics. We'll look at it again when I'm in class to be able to kind of show the operation. So that servo actuator is going to actually physically move the flight control. And it can, in this case, it can deflect, we'll call this an elevator, it could deflect it up or down. But when we looked at the servo valve, part of that servo valve is it's going to have a feedback or follow-up mechanism in it. Because if we only, say, push the yoke forward a little bit, we only want the trailing edge of the elevator to deflect downward slightly. We don't want it to go full down. And so that's where the feedback or follow-up element comes in, is that as the flight control deflects into the position we want it, that feedback or follow-up device is going to have to cut out operation or stop the continued movement of the control when the flight control reaches the position we want it to go to. And it can also provide verification of movement or change. In the case of something like an aircraft with an ICAS system, there will actually be sensors that can send a position indication in addition to telling the control mechanism, the hydraulic actuator or electronic actuator, to stop moving the flight control. They will send a signal up so that on ICAS we can actually see the control surface position. And so that creates this loop of control where we get feedback back up somewhere around the input, going into the control portion. So this is demonstrated in the video that I have linked there, which will also be posted along with this one. So I'm going to talk about kind of 7 main flight control, actuation, and control methods. And here's kind of the order, and the order they go in is an order of complexity, but also kind of an order of development when these were developed. And so we'll start with our mechanical controls, like what's found on most small aircraft. And this also, some of it is based on size. So then as aircraft get bigger, the forces are too great to use purely mechanical means. And so we add some hydraulic boost. And this is very similar. Mechanical with hydraulic boost is very similar to a lot of what most of you experience probably when you're driving your car with power steering. And then we go to hydraulic with mechanical control. So this is purely hydraulic operation with mechanical control. And at this stage, this is where hydraulics become extremely critical, because the mechanical control, all it's doing is moving a valve position. If there's no hydraulic pressure, then the flight controls won't move. And then we get into hydraulic with electrical control. So rather than having mechanical linkages, we control the hydraulic actuators and ultimately the position of our control surfaces electronically. We can have electrical control and actuation. Often you'll see this in things like flaps or slats. Sometimes they use electric motors instead of hydraulics to drive them. It can also be things like nose wheel steering and stuff like that. And then some aircraft even do go into fiber optics, and they have light control. And you've got light control connected to electrical actuators. You can also have light control connected to hydraulic actuators. And most aircraft use some combination of these different systems. So let's start looking at what these are. So the first one, mechanical flight controls. These are your cables, the flight controls where from the yoke to the flight control surface itself, you have things like cables and bell cranks, push-pull rods, torque tubes, and these are going to provide limited power. So on small aircraft at lower speeds where there's not massive forces on the flight control surfaces, a person pushing and pulling and turning and twisting on the inputs on the controls has enough limited power in order to operate them. And typically the largest aircraft you see that might use purely mechanical controls are some of your turboprops in about the 30 to 35 passenger range. The next type of flight controls are hydraulically boosted mechanical flight controls, and these are what are called power assisted. And so in this case, you have a direct connection between the stick and the yoke surface. So they use the things like cables, bell cranks, push-pull rods, torque tubes, etc. And they can, in this case, the flight controls can be moved in the event of hydraulic or electrical system failure, but they're not going to be easy to move. They're going to, the crew or whoever is moving the flight controls is going to have to overcome a lot of opposing forces, both from the size of the flight controls as well as the air stream across them. Right, the more you try to deflect a flight control at high speeds, the more air is pushing against it. But these work similar to the power steering in your car, where even if you lose hydraulics or electrical, you can still move the flight control, but you're going to have to work hard to do it. And so, in that video that I have linked, you can see from about the 2-minute to 5-minute 42 mark, the video will talk about and demonstrate how power-assisted flight controls operate. And then the third thing I'm going to talk about in this video before taking a break, is mechanically controlled hydraulic flight controls. And so these are the first ones where we no longer have a physical connection between our stick or yoke and the surface. And so we cannot move flight controls with a total hydraulic system failure. And so in order to make up for that, most flight controls, all your critical flight controls, anything that's going to control yaw, roll, or pitch, is typically going to have 2 or even 3 actuators attached to it, and those are going to be powered by the different hydraulic systems. So you may have systems 1 and 2 powering the left aileron, and systems 2 and 3 powering the right aileron, or system, and maybe all 3 systems have actuators tied into the rudder. And so here we have 2 types of control valves. So we've talked about the power control unit, servo valves with feedback. Those are known as PCUs, or power control units. And those are demonstrated in the other video that I'm posting with this, that discusses hydraulic flight control actuation. That's part minute 542 to the end. The total of that video is about 10 minutes long. And so those are the ones that allow for partial servo control. There are cases too where we have full travel actuators, and those are things that are either all the way open or all the way closed, or all the way extended or all the way retracted, and they don't have that feedback or servo mechanism. So those are used more for something like a dedicated ground spoiler, where when the aircraft lands, the spoilers fully extend, and that's the only time they ever extend. So there wouldn't be any reason to put a more complicated feedback servo unit on it. But for things, again, like the ailerons, elevators, rudder, roll control spoilers, and things like that, a servo feedback system is required. So you may have either a PCU servo feedback system or a full travel actuator. So if we look at kind of the general assembly of something like this, here we can see we have the cockpit flight deck in the upper right, and we've got, most flight decks have two yokes. So here's our two yokes, and this is showing the aileron system. And those two yokes are going to control a whole bunch of cables. Those cables run to different bell cranks and pulleys, which change the direction. And then those have more cables running out. And those cables, you can see here on the left, they go to two PCUs. So you probably have one PCU might be running on hydraulic system 1, and the second PCU is running on hydraulic system 3. And then some of the cables go out here to the right wing. And again, the right aileron, two PCUs, maybe you have system 2 and system 3 running that. And so any one of those can provide roll control. You don't have to have both ailerons working, for instance, for roll control. One aileron will do it. It'll lose some what's called roll authority or some authority. It won't work as well, but it'll be good enough to fly the airplane to be able to land it in the event of hydraulic system failures. And so this is how this shows kind of how they're all attached together. But again, once we get to this connection at the actuator, so the point here where the rod coming off of this wing sector, this input rod, connects to the PCUs, it does not physically have the ability to move the flight control anymore. All it's doing is moving hydraulic valves inside the PCUs. And so that's where, keep being able to have hydraulics available becomes incredibly critical on an aircraft like this. So I'm going to stop at this point. We'll continue working through different kinds of flight controls next time. But at this point, I encourage you to watch the video that talks about the different types of hydraulic flight control actuators that was linked here and here. And then next time we will continue moving forward with the rest of the flight control and actuation systems.